Hi, and welcome to the first and we haven't signed up. We've never had an event like this, so here's a brief overview of what this will look like, a network makeover view, if you will. Between now and December 13th, we're giving away over 50 prizes, including a grand prize $50,000 network makeover made up of your choice of Ixia hardware and software. But because we know you want to win, we want more than just one winner. We're also giving away 5 swag bags each weekday with winners drawn on camera right here. And if you're signed up, you could win. Today we've partnered up with Scout and we're drawing our first 5 winners, and these are some of the best swag bags we've ever given away. At the end of the video today, we also have an interview with Ferro from Packet Pushers discussing the implications of edge networking in 2020, so make sure to stick around for that. As I said, each weekday we'll have a new video that will go live at 10 a.m. Mountain Time, that's -7 UTC, and it will be on the Ixia TV YouTube channel, and at the same time the video on the main event page will update so you can see it there as well, or here if that's where you're already watching it. The videos are a lot more than just a prize drawing too. Mike, who we've been affectionately calling Packet Boy, has painstakingly put together a daily tech tip which digs into a new topic each day. Today we're looking at taps and how they stack up against span ports. But in the coming days, Mike will cover topics like inline security, threat intelligence gateways, and active network monitoring. Since we're on that topic, let's jump right over to Mike for the topic of the day, taps versus spans.
Hi everyone, my name's Mike, and let's talk about some data. It's a given that your security and performance monitoring tools need detailed information to protect and optimize your network. But how do they get it? Today we're going to take a look at how your tools get the data they need. Now, when it comes to identifying a security breach or pinpointing the root cause of network latency, your monitoring tools need the detailed data found inside network packets. By utilizing data like the source of a request, the path of a request travels, and any other resources accessed along the way, tools can spot patterns and anomalies that help identify security threats and isolate performance issues. The trick is to provide tools with all of the relevant data they need from every corner of your network. Missing packets skew results, and blind spots can become hiding places for malicious traffic. Historically, IT teams used mirror ports in their switches, also known as span ports, that copied data and fed it to their monitoring tools. Using span ports is fast, it doesn't require any additional equipment, but it isn't free. Mirroring uses one of the switch's limited number of ports, and there are other disadvantages as well. Span ports don't forward corrupted packets, and when switches get congested during traffic-heavy periods, they tend to drop packets to maintain their switching ability. And because this ultimately limits the data that gets sent to your tools, you'll never get the full picture using this approach. In addition, span ports are also a security threat because they're susceptible to external hacking. In response, many teams are shifting away from span ports to network taps. In contrast to a span port, a tap can be deployed anywhere in your network. They copy every packet, even those with errors, and they forward them to your tools with zero latency. Taps are simple devices with a long mean time between failure, MTBF for all of you guys playing at home, and if a tap does fail for any reason, traffic defaults to the wire, maintaining your network availability. Plus, because taps have no IP address, they are more secure from hackers. However, the biggest advantage of taps is that they separate monitoring from the live network. This means monitoring tools can be deployed and maintained without impacting the flow of network traffic, which helps you avoid network downtime. Now, if you decide to use network taps, you'll need to use a tap that matches the type and speed of each of your network links. Fortunately, there are plenty of physical tap options out there for you to use, including copper taps and modular high-density taps for fiber links that come in speeds from 1 to 400 gigabits per second. Then you've got patch taps, which eliminate the hard shell around the tap to reduce the footprint and add deployment flexibility, aggregator taps, which combine traffic from multiple links, and finally, regenerator taps, which can send traffic to 2 monitoring tools simultaneously. Sounds simple enough, right? However, things get a little bit more complicated in virtualized environments. The issue is that traffic that moves between virtual machines on the same physical host, otherwise known as east-west traffic, doesn't flow through physical taps. Therefore, these packets are completely invisible to your monitoring tools unless you have a virtualized solution. Virtual taps work inside the hypervisor layer, making copies of packets that move between virtual machines to eliminate those pesky east-west traffic blind spots. In today's distributed networks, which feature a mix of physical and virtual traffic, you compare physical taps with virtual taps to make copies of all the packets flowing through your network, ensuring that your security and performance monitoring tools never miss a thing. Now, unfortunately, that's all we've got time for today, but I hope I've wet your whistle to learn just a little bit more. For more information on network taps, check out our solution brief entitled Why Taps Are Critical to Network Visibility and Security.
Now, Mike mentioned that solutions brief that is inside of one of the event exclusive libraries. We know that having a couple minute tip video is just the tip of the iceberg for these topics and probably won't be enough for you. So as part of the network makeover, our experts here at Ixia have handpicked some of their favorite white papers, ebooks, videos, and webinars around certain topics. And those are only available for those of you who have signed up for the event at makeover.ixiacom.com. You can get to those on the main event page down at the bottom. I believe we have a graphic prepared. Yeah, so you can see that there are dedicated libraries for data access, which digs into network visibility and has that solution brief Mike mentioned, and data processing, which, by the way, digs into packet management and the packet broker side of network visibility. And that one's extra fun because we have a couple solution briefs on that page from Forescout, who has partnered up with us for today's part of the event. And there's also a security monitoring library and an edge monitoring library. Don't forget, we also have the interview with Greg Ferro from Packet Pushers coming up at the end, which is also on the topic of edge networking. So we'll jump to that right after our drawing. Remember, sign up at makeover.ixiacom.com if you haven't yet, and you can come back each day between now and December 13th to get an extra entry. Each entry accumulates, so you don't have to sign up each day, but it does help your chances of winning. I'm about to draw 5 swag bag winners, and like I said, these are some of the best swag bags we've ever given away. I think we have a couple graphics we can show. There's at least a shirt and a beer mug, or juice mug, or kombucha mug if you're more into that, or even water if that's all you drink, and you can pat yourself on the back and jog off into the sunset. But we're giving away 50 of these swag bags between now and December 13th. And on the 13th, we're also drawing that one lucky grand prize winner who will win a $50,000 network makeover made up of your choice of Ixia gear. This can be hardware like taps, packet brokers, bypass switches, and threat intelligence gateways, or software like some of Ixia's industry-leading network performance monitoring tools. And if you did the math, we are giving away 5 swag bags per day starting right now. Today's winners are Tynan Liu, Clint Milner, Biff Clark, Chris Lofton, and Brian Koki. Congratulations to those winners. You should see an email from us shortly. If you have questions or comments, let us know. You can put those in the comments section over on YouTube, or also let us know on Twitter. And also make sure to tune back in tomorrow at 10 a.m. Mountain Time, that's -7 UTC, to see if you are a winner. And now it's time for the interview with Greg Ferro and a couple of our Ixia experts. Greg is a world-renowned thought leader in this field, hosts multiple podcasts in the Packet Pushers Network. Over to you, Greg and team.
Thanks, Daniel, for that introduction. My name's Greg Ferro from the Packet Pushers podcast, and I'm the co-host and the co-founder, where we talk a lot about networking. We often talk about ourselves as going nerdy on networking. I'm a 25-year survivor of enterprise IT, and I'm looking forward to the conversation today because we don't often talk about the networking edge. We always just talk about the core of the network. So, hey, good stuff.
Hey, thanks, Greg. I'm Taran Singh. I'm from Keysight Technologies, and I look after the network visibility products. Good to be here.
And I'm Craig Reynolds, also with Ixia Network Visibility Products. I look after some of our edge networking strategy and products in and around the edge network. Glad to be here as well. Looking forward to it.
So let's go straight into the topic that we want to talk about today, which is talking about the network edge in the 2020. And I think just to set the scheme for that, once upon a time, the network edge was a router, which compared to what we do today is a pretty dumb thing. A router is kind of dumb, does one thing, packets in, packets out. And all of a sudden, we're seeing the network edge become much more complex, much more different. We're seeing SD-WAN arrive, talking about 4G, 5G as bandwidth. We're talking about public internet. I mean, let me ask you, Taran, what do you care about the network edge? What do you think is different about the network edge in 2020?
I think network edge does mean a lot of things to different people, but from our vantage point, from what we see customers do, it is about connectivity as far out in the analog world as you can get. So you can think of the most classic definition. You're in the office, you're working, you have an SD-WAN connectivity perhaps, or direct connectivity. That's edge of the network. Yeah, classic definition. But it's a whole lot more than that. Think of the superchargers around the Tesla supercharging stations, they are at the edge of a network. There's full connectivity. That's an edge. You can have more and more e-commerce distribution warehouses being built everywhere. They are at the edge of the network. That's the edge. And the one common thing they have is that they're all very diverse in nature, in size and scale. And unlike in the past where you had centralized data centers for networking and everything else, now the edge does a lot of the smarts as far out on the edge as you can get. So for us, for me, my definition of edge is quite diverse. It means the smallest things to the largest things, but it has to do with being far out in the edge, doing the business activity that you're doing. And I don't know if Craig, you have, and from your purview, what you think of it.
Yeah, no, I think that's right. I mean, that's the key thing. You know, I heard conversations that range from, hey, we've been doing CDNs for years. What's new? To, hey, you know, edge is going to eat the cloud. So it means a lot of different things to different people. I think, Greg, as you mentioned before, I think some of the technologies that you mentioned maybe are sort of enabling some of the ability to even have this conversation about doing more at the edge with the bigger bandwidths on 4G and 5G. You know, some of the enterprises moving from maybe these direct links to sort of IP based. And I think some of those technologies and the needs they are demanding from those are a lot of things that are driving this need for edge compute. And like Taran said, I think at the end of the day, it's where does that transaction take place? Where does that business need happen? And sort of the applications and the data, essentially at the end of the day, it's all about the data and what are you trying to do with the data and where are you trying to do it.
I think one of the most interesting things that I'm seeing at the moment is the micro data center. So you talk to IoT companies about what they're doing, and they're talking about a factory, which is a unique situation, but the factory, and they're going to plan to flood that data center, that factory, with thousands of sensors. And then inside the factory will be a micro data center. So all the data will stream, the telemetry will stream off the sensors back to the micro data center in the factory. And there'll be some, crunching of the data, and then it'll wander off up to the cloud, right? So now you actually have two network edges. You actually have the sensors and the micro data center inside the factory, and then you have another edge where the micro data center is communicated back to something in the cloud, and then a big AI ML mystery thing comes out and does something with the data and turns it into valuable, meaningful business data. So I think there's that, and I think one of the other interesting things that's changing the nature of the edge for me that's not IoT, but is actually space networking, which is what I call it, space networking, and that's where companies like SpaceX with their Space Link, and they're building a broadband in space in medium Earth orbits and low Earth orbits. And they're talking at the moment that they can actually reach latencies better than undersea cables or better than MPLS in certain circumstances. Now that remains to be seen. Color me a little dubious, but so vendors like to say a lot of things, and let's see what really happens. But I think, if those sorts of things come about, there's a lot of change coming in the way the network looks, but there's also a change coming in how the network looks too. So that, the router that you put into your house today is the edge, but increasingly you're going to have hubs in your house, like your Philips Hue hub. That's actually the edge of the network as well. Because from a data point of view, it's actually getting much further out. So it's not even as clear cut as, so I sort of look back on the days of the router and go like, the router was the edge of the network. They were good days. We knew exactly where we were. You know what I mean?
Yeah, very true. And I was going to add that, because you've mentioned so many different technologies, right? A smart home hub. I mentioned Tesla supercharger. You mentioned space technologies, SD-WAN. We said, and we could keep naming them. The what's actually troubling is also that this trend is pretty real, because we're going to have a lot more analog digital transactions happen in the edge. And the one thing that we're seeing is, how do you have accountability of those edges with respect to what you need to do for your business? And what I mean by that is, really, it comes down to, is it safe? Is it fast? Is it reliable? How sure am I? Am I complying with all the things I need to be doing in the data center, but now applied to the edge? And that's a big challenge for any of these different industries that we're talking about.
Yeah, and it's all those things while providing that business need, right? That transaction, if you will. It's some, sort of that meeting between the digital and the analog world, as you put it a moment ago.
Yeah. So one of the things, so the thing that we focus on here is how do you go about thinking and monitoring the edge, right? And so we can think of things being very different to a data center. One of them is scale. The sheer number of these devices, like you mentioned, sensors being one layer of a network, if you will, and then the very small local micro data center that processes the data close to real time, but then in pseudo real time has to send it out to the cloud because it now has to actually do the next level of introspection on that data, right? That's a lot of data, okay? Terabits and terabits of data on a day-to-day basis, right? So what's important there is scale, huge, right?
Yeah.
And the
I
other
heard
one
it.
is, in the same context, is this diversity of what you have as the edge, right? Diversity of the type
Yeah.
of devices as well.
I think I don't think scale matters. I think scale matters in the sense that if you've got a 10 gig or 100 gig pipe, you need a tool that's going to work at that speed.
Yeah.
I think really what we're talking about here is typical data center monitoring is effectively zero. Most people who build a data center sort of go like, nobody's complaining. Don't do anything. Let's just hold up, like, or maybe we've got some SNMP monitors or some vSphere consoles or some, that sort of stuff. There's really not a lot of sophistication. So I think it's one thing to say, we've got to think about scale diversity and you're quite right. And we do, but I think we also need to recognize where we're coming from, which is a lot of companies just don't have anything. And the thing that they're missing is they've got no visibility. If I suddenly take, today you've got a factory out there and you've got 10 factories. I was talking to a pharmaceutical. They've got over 150 factories around the world. Do you know how many data centers they've got? 3. So all of a sudden, if you're talking about putting a data center in every factory, they've got to completely transform the way they approach compute, how they're going to do remote administration, where's the traffic coming. And I think all of this comes down to this visibility and analytics. It's got to be smart visibility, not just capturing packets and showing me what's going on, and not just, analytics isn't just like, lots and lots of packets, lots and lots of bits per second. It's got to be meaningful. So I guess I wanted to find out from you guys, how do you take monitoring and turn it into something useful, like, it's broken, or even better, it's not quite broken, but it's kind of sort of broken, and we can tell you what's kind of sort of broken.
Yeah, you want to take that, Craig?
Yeah, I mean, and I think there's a couple of different kind of key ways that customers will, the one, and you actually raised a good point, is who is actually doing the monitoring in the first place, right? Much less sort of the sophistication of it. But, there's kind of 2 key ways that we see customers doing that. One is, I'll call it synthetic monitoring, active tests. It's kind of it's a proactive way of, scripting and sending traffic that should behave in a certain way. And then seeing if the network behaves in that way. Now, the nice thing about that is that, we just talked about all these different sort of endpoints, if you will, and between those kind of endpoints and your core, for lack of a better phrase, and again, these are all words that mean different things to different people.
Yeah.
But there's a lot of different things going on, and it could be now a cloud network that you don't own, right? If it's talking about some sort of cloud service that you're provisioning. So you can actually see what's going on through those hops and understand that, right? Where even though you haven't instrumented what those networks look like. So the nice thing about that is it's proactive, right? So you don't have to wait till the user sees a problem. If you're spinning up a new service, you can test it before it's active to live users, those sorts of things. The downside is it's a test. It's not sort of real traffic. It's not real time. You don't see what the user is actually doing. And so that's what we'll see a lot of times customers use. There's a variety of tools, everything from instrumenting the application with, application performance monitoring to different network performance monitoring. I've heard real user monitoring, end user monitoring, digital experience, a whole bunch of different words for what that is. But to your point, at that case, it's, a lot of times packets are involved and deeply going in and saying, okay, I can actually see what's going on in detail of the transaction. And that gives me some tools if I really want to dig down and triage, right?
I think there's a few things here. So there's a couple of things there. There's lots of different ways to monitor networks. One way is to capture the packets in some way and do analytics on that. Another way is to do flow data collection and sample it, and that gives you a rough and ready type of thing. And then another way that's to do it is to actually do synthetic transaction monitoring, which is what you've said. So there's features of synthetic transaction monitoring which I really like, which is I can program the transactions that I want, and then I can see the variation over time. So instead of monitoring,
Right.
packet flows and trying to extrapolate and produce a dashboard chart. Having a synthetic transaction means I can just tightly focus in on that one thing. And of course, I can have lots of synthetic transactions. But I think the thing that I really like about synthetic transaction monitoring is the unattended testing. So if I want to do a volume test, so
Right.
maybe you just upgraded your WAN site from 100 meg to a gigabit, and you want to know, did they actually give me a gigabit? Did I get, here's a great one for you that synthetic transaction can get you, MTU. One of the people I was speaking with recently, apparently the telco changed their network MTU and it jumped from 1538 to 1480. And they didn't know. And there was all these problems happening in their network because their packets that were previously working suddenly stopped. Whereas if you've got a synthetic transaction which just sweeps the MTU and comes back to you and tells you what's going on, then all of a sudden you've got an automated test that maybe you only run that once a day,
Right,
but the one time that it goes off, you're like, got ya. My service provider's let me down again.
Yeah, I think SLA is a great example. I mean, we even as Ixia, and I want to say, Tara, maybe but I think it was with our unified communications provider. We all have issues with these tools that we use, the ones we're using now and all that kind of stuff. But there's SLAs related to that, and we implemented one of our internal tools and for doing synthetic tests, and we actually ended up getting back, I want to say over a couple of years, it's around a couple $100,000. So it was a meaningful kind of trying to hold your service providers or software providers, SaaS providers, to the SLAs that they're expected to give, and a tool for that.
Yeah. No, I want to touch on the other two you mentioned, right? Real user monitoring and flow, right? So let's think about the edge. You've got many places. You don't have the luxury of looking at packets 24/7. You just don't have the luxury for any number of reasons. You might not have on-site data centers that are capable of doing that. You may not even have the skill set to actually do that. You may not have technologies in place, right? So one of the other ways that approaches to monitoring at the edge is going to be you selectively look at packets. But what's the intention? The intention then would be, and this happens, by the way, with customers who are in a more of a mature life cycle of visibility and monitoring, is for forensics. If you're chasing a problem and you need to know what things were looking like before, now, and possibly in real time, you'll use synthetic monitoring because you can actually instrument everything just the way you like. But that's very different than you finding a problem or you being advised of a problem. And at that point, you need to switch into tools and methods by which to get access to packets, because there's nothing better than having access to packets. You don't need it 24/7, but you do need it for forensics.
So you're talking about triggered packet capture. So if I see something happening,
Be a great example.
if an SLA is breached or an event happens, then suddenly the remote node, the Ixia node that I put out at the edge of the network, triggers and starts capturing packets. Not every packet, but packets for a specific, like you talked about voice calls. Not that, I mean, honestly, it's 2020. Who cares about voice calls? But some people do, right? You'd think that everybody be using smartphones by now, but hello, welcome to 2010. But when it's not working, people do get upset. So if you could start capturing those packets and get deeper into insight, maybe you can start to see, the retries start to blow out, the jitter goes all swanky, and you go, look, the service provider's got a problem here. So is that what you're saying? You trigger that capture and then away you go?
Yeah. So, you give an example of voice, but we can go even simpler. Point of sale device. If something is not working, is it the network? Is it the application? Is it a bit of both? Is it just your site? Is it somewhere else? Now, you might know this because you just got a phone call about it from somebody at that site. But at that point, you have to have at your disposal not just active monitoring technologies, but a way to actually capture what's on the network. Is traffic emanating from that site that is meant for point of sale transactions, right? So yeah, I do mean it, because at some point you're going to move from just monitoring to triaging, and to do that you need to have diagnostic tools right at the edge. And that's so that's one example.
So you have to define what your reaction is. At some point, monitoring's not enough and you have to react. You have to be able to narrow it down into the cause so that you can measure, what you can change, I guess.
That's the goal at the end of the day, right? To fix it.
Yeah, and fix it and verify. And the other extreme case is, I happen to be on a Wi-Fi connection today, right? So a lot of times we just take it for granted, right? Like you said, voice call, it should just work. It's 2020. What's MTU got to do with it, right?
Yeah, that's true.
Right? But and when it works, it's all the same. But when it doesn't, now you have to chase things. So another extreme example would be everybody gets on Wi-Fi as they walk into the building, and maybe the authentication services is far out elsewhere, and it's slow to respond. Now, the complaint would be, I can't get on Wi-Fi, but that's actually, and it's totally factual, except when you look into it, you realize that it's the authentication service that's not responding. It has
Oh, it's always the
nothing.
DNS. It's not always the DNS. We
Right. And so being able to, exactly. So to be able to get access to more of the non-network type of instrumentation is very relevant, because now you're not interested in network traffic. You're interested in authentication specific traffic, right? So a lot of that is predicated on the type of network you have, but also what is your definition of that edge site, and what is it that you're trying to monitor and triage as well.
I think another thing about the Exia product that I like is the independence. So a lot of people are going into SD-WAN these days, but what they're not doing is rolling out entire SD-WANs. So they're usually picking up a certain number of sites, and they're starting here, and then there's some sites over here which are on routers, and there's some site, and then they think, you know, and sometimes their networks are in multiple phases of SD-WAN, shall we say. Some of them are running you know, one of the things that we've been talking about over Packet Pushes is the evolving nature of SD-WAN, right? There's old SD-WAN. Can you believe it? There's actually old SD-WAN.
Yeah.
And then there's the next generation of SD-WAN, which has got security built in. So we're already seeing the first generation of SD-WAN products sort of being obsolete. And, you know, the second generation. If you're in that situation and you're relying on the SD-WAN vendor to do the analytics for you, that's great because the analytics are built in, but you do still need to monitor your old, and you need to monitor the new, and you need something that's going to bring all of those differences together. So if you've got a traditional enterprise WAN, and over here is an E1 with a router over there, but over here is your fancy panty latest generation SD-WAN with 4 DSL and 2 cable connections on it. How do you match up those experiences so that when you go back to the business, you go like, you can say, look, no, we're monitoring the statistics. This user experience is that user experience is, you know, this is worse. We can prove that the E1 is working worse than the cheap internet we're using over here, sort of thing. And I think that monitoring that's independent of the actual networking assets is important for certain people. For there's a use case for that.
Yeah, and I think you alluded to another one too, which is, you know, ideally, you know, there's some sort of uniform deployment of your SD-WAN solutions, and, you know, but you highlighted old and new. It could be different providers for different parts of the, maybe in a, you know, your European region and versus your Americas, or, you know, whatever the case may be, and kind of having a sort of unified approach to monitoring all those the same, even though they're not implemented the way. And, you know, other example, you have different brands of different devices that have different capabilities, and sure, you can, you know, integrate all those and have some masterful, you know, in some Shangri-La type of world where everything works out perfect and you have one dashboard to look at, which we know doesn't actually happen. But having a unified approach is valuable as well. And I'll flip that around. You know, our conversation has mostly been around enterprises, but yeah, you know, and we're talking about sort of, you know, advancing the ball on what you're monitoring or whatever. But I'll just roll back and give another example of edge where, you know, service providers, and I'll even be more specific for the use case, but broadband, you know, you're providing managed broadband, and, you know, your customer is, given a retail chain, I'll say, I don't know, it'd be like KFC. We'll use KFC for the example now, right? But you've agreed with KFC that, hey, everywhere you have a store, I'm going to provide your broadband service, right? Whatever that looks like. And of course, any given provider today, and even now, I'll just talk the US, but clearly, if you're talking about different countries, that adds another layer of difficulty. But, you know, no one service provider has coverage in all those areas, right? And so if you start overlaying the map of what that coverage area is for a service provider, and then overlay the map of where all those retail branches are, which, by the way, you know, may not even have a gig link, may have, you know, much less of a link. Like we didn't even talk about connectivity in this sort of edge kind of conversation.
Yeah. This is where service providers like, I had a guy, somebody the other day asked me a question, and he was working with a Verizon, and his branch site went out. And it turns out that after 2 days, AT&T had deprovisioned the circuit at the edge, but Verizon was saying that it wasn't their fault, right?
Exactly.
So, you know, how do you that's okay, because at least it was broken, right? You knew something was wrong. The real problem was, and now he realizes that the real problem here is when the network who's subcontracted to his primary telco, to his subcontractor, he's got no way of proving who's at fault, and
That's
no
exactly
data to
right.
show
Well,
them and make this right. So
yeah, and and you said it, 2 days of trying to triage it. Like, I don't know what the site was. I don't know how much that was costing them a day. It's funny. Like, I heard somebody say this and it stuck with me. It's Boston Market can't sell you a chicken without their IP service. Right? I don't know if you have Boston Market or you like Boston Market, but that's aside the point, right? It's like literally the importance of IP just to make a sell. Like, you don't give somebody cash. You can't walk out of the store. And so the impact of not, you get that call that you're describing and you're like, do I call KFC's enterprise, or do I call, use the example of AT&T, who maybe is the in provisioning? And the fact of the matter is, you're basically eating up all the profitability you might have had for that set of stores with the sending a truck roll, doing the tech support, and all those kinds of things.
Yeah. I don't really care about the business case because I don't get paid any extra for doing a great job. All I really want is for the executives to stop harassing me, right? I'm that guy, right? I'm the guy. Okay. And normally there's a semicircle of executives standing around the edge of my desk going, why is the network a problem? And you're going, I can't see anything. You didn't buy me any tools. What do you expect me to say to you, right?
Fair enough. So the business will leave you alone more if you're able to manage the cost.
Mean time to innocence, I think, is the term that I've used quite substantially.
Is that right?
I'm going to use that. That's great. Mean time to innocence. Yeah. So
some people worry about mean time to repair, or mean time to recovery, or recovery point objective, or recovery RTO, no, it's mean time to innocence when it comes to the network, buddy.
I'm going to use that. We've coined that. I'm going to refer to it. That's right. But so if you can instrument, then, this point that you're saying, so AT&T owns it and then the customer's going to let your network, that link, just having SNMP, it's up or down is incredibly useful and an advancement of the ball, and add to that some of this.
My point would be is that up and down is easy enough because works doesn't work. Problem, not a problem. It gets much worse when, AT&T's provisioned a 1 gigabit circuit, but Verizon configured a 500 meg circuit. And this happens, right? Yeah. Or there's an interconnect problem, or there's packet loss somewhere, and you've got nothing to put, when the sales rep comes in and you go like, this circuit's a problem, and he goes like, looks fine to us. But if you can pull out the stats and go like, see this is your jitter running at, 200 milliseconds on a circuit that used to run at 20 milliseconds, and the latent, blah, 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 jitter, latency, whatever, want a refund. Well, I tell you what happens in a real big hurry straight after that, right?
Yeah.
Yeah. That's the sort of basics, but then you build it. I think the other thing about the Ixia thing that I like is your virtual nodes. So you've got all of these, we're talking about the edge of the network, but the edge of the network also includes the cloud and your data center. So I like to think of my own data center as an edge, because the network is the core. Sure. And I like to think of the enterprise data center. And I want to be able to put probes in VMs, in the cloud. I want to be able to put probes in the data center. And I want to be able to run those probes anywhere that they need to be. And you do that as well.
Yeah, absolutely. And, we're talking that one edge, you talk about the kiosks or something like that telemetry, anything that runs software, right? That's a potential area you probably want to do. And trying to get packets from it may not make a lot of sense, but if you can instrument it, then
it's not just a hardware thing. Yeah.
Right.
You've got, I think the important part here is, you've got hardware devices, put them out on site, you can use them and there, but you've also got software devices. And if that makes sense to you, and if you're using an SD-WAN platform that runs some NFV instances on top, gives you some containers or some VMs.
Absolutely.
There you go. There's your probes, there's your remote access, there's your tools. Well, I think we should start thinking about wrapping this up, because we're starting to bloviate and starting to repeat ourselves, because that is the excellence that we bring to this experience for you, the audience. So have you got any closing thoughts, Taryn?
Yeah, I was going to say that we've talked a lot about edge, and